Gnu Grub, or Gnu Grand Unified Bootloader, is a key component of the Gnu project, serving as a bootloader for Unix-like systems. It adheres to the Free Software Foundation's multi-boot specification, enabling users to select from multiple operating systems or specific kernel configurations during the boot process on multi-boot systems. Developed from the Grand Unified Bootloader, a playful reference to the Grand Unified theory, GRUB's functionality is crucial in managing the booting process of computers. During startup, the Basic Input/Output System, BIOS, locates the primary bootable device, typically the hard disk, initiating the execution of the initial bootstrap program from the master boot record, MBR, the first sector of the hard disk. The bootstrap program is constrained by the sector size, historically 512 bytes, necessitating compact design. While newer advanced format disks with 4096 byte sectors exist, they are accessed using 512 byte sectors. The legacy MBR partition table supports up to 4 partitions, with limited space available for bootloader code after accommodating essential information. Complex bootloaders like Gnu Grub are split into multiple parts due to space restrictions, with a small piece residing in the MBR and larger sections stored elsewhere. GRUB's approach involves understanding the file systems directly, avoiding the need for manual MBR updates when kernel images are changed or moved. By containing drivers for supported file systems, GRUB streamlines the booting process, accessing kernel images using actual file paths rather than hard-coding locations. This method eliminates the reliance on map files and enables smoother system updates, despite the increased size and complexity of the bootloader. GRUB has evolved over time, with GRUB Legacy, version 0, prevalent in older Linux distributions, while GRUB 2, rewritten to supersede its predecessor, is now the standard for most Linux distributions. This version of GRUB's design facilitates efficient boot management by integrating with file systems to enhance bootloader performance, demonstrating its significance in the realm of system initialization and management. GRUB Legacy, in version 0, GRUB Legacy, utilized a two-stage approach within the Ubuntu 9.04 installation. The master boot record, MBR, typically held GRUB Stage 1, which could also be a standard MBR, leading to the chain loading of GRUB Stage 1 from the boot sector of the active partition. Stage 1 loaded the subsequent stage by accessing disk sectors situated near the disk's beginning within the first 1024 cylinders. Usually, Stage 1 loaded Stage 1.5, residing in the initial 30 kilobyte following the MBR and before the first partition on the hard disk. Should space be unavailable here due to various factors like unique partition tables or disk drivers, the installation of Stage 1.5 would fail. Stage 1.5 contained file system drivers enabling the direct loading of Stage 2 from any known file system location like /boot/grub. Subsequently, Stage 2 would load the default configuration file and any requisite modules. On the other hand, GRUB 2, version 2 of GRUB 2, involved MBR versus GPT partitioning and boot sequence for systems operating with BIOS firmware. The boot process entailed the writing of boot.img, Stage 1, within the initial 440 bytes of the master boot record, or optionally in a partition boot sector. This component addressed diskboot.img through a 64-bit LBA address, with diskboot.img existing as the first sector of core. IMG aiming to load the remainder of core, IMG identified by LBA sector numbers. Depending on the disk's partition scheme, core.img, stage 1.5, found its place between the MBR and the initial partition on MBR partitioned disks, ideally allowing a 1 MIB gap for alignment. Conversely, on GPT partitioned disks, core.img resided in its partition earmarked as BIOS GRUB, with a minimal size of 1 IMB, while Stage 2 dealt with loading necessary components from /boot/grub/i386pc/normal.mod. Post-loading of normal.mod, necessary operations like parsing grub.cfg, loading modules, and presenting the user with a menu ensued. GRUB, across versions, allowed for the management of boot options, kernel parameter editing pre-boot, and spawning a command line for fine-tuning. Depending on the situation, GRUB would load the selected kernel into memory or pass control to another bootloader through chain loading. UIDs served as a consistent means of identifying partitions in scenarios where hardware configurations altered unpredictably, or disks moved across systems. Gnu Grub leveraged UUIDs for partition identification, created during formatting and remaining unchanged throughout operations. While the file grub.cfg configured grub settings to be executed at each startup, its absence led to a command prompt. Various Linux distributions embraced Grub 2 as their primary bootloader, with Ubuntu, Fedora, and other major systems implementing it from 2009 onwards. Outstandingly, Grub 2 aimed for enhanced cleanliness, robustness, portability, and power, evolving from PuPA to address a wider array of platforms and functionalities. Across the years, different variants of Grub emerged, such as for Open Solaris, Google Summer of Code projects, and the trusted Grub with TPM support, broadening the utility and versatility of the Grub bootloader. Various tools are available for configuring Grub, such as Startup Manager and Grub Customizer, which provide graphical interfaces for Debian-based distributions. Startup Manager ceased development in 2011, while Grub Customizer is also compatible with Arch-based distributions. Additionally, Boot Repair is a tool for fixing boot-related issues with GRUB and Windows Bootloader, supporting multiple Linux distributions under the GNU GPL license. Grub 2.win is an open-source software for Windows that enables booting from a Windows directory and customization of the boot menu. While Grub is the default choice for many platforms, alternative boot managers like Refind and CloverFi offer user-friendly experiences and graphical OS selection. Non-graphical alternatives include System to Boot, a lightweight UEFI-only boot manager,